staying in the Gulf of Finland, Miina will tell us something about tools towards environment. Miina, could you take the microphone already while I'll
may I
get up here?
sit it?
Yeah, sure. There you go.
Thank you very much for this opportunity to come here and tell about our TOPCONS project and the marine spatial planning tool that is being developed in this project. Actually, I'm substituting researcher Riikka Venesjärvi in this conference. She's from University of Helsinki and the responsible scientist developing the tool. This project itself is an MB-funded Finnish-Russian cross-border cooperation project closing at the end of this year. And other partners in this project are Kotka Maritime Research Center, Finnish Environment Institute, Geological Survey of Finland, University of Helsinki, Metsähallitus, and Finnish Game and Fisheries Research Institute, and we have 3 Russian partners, Russian Academy of Sciences, AP Karpinsky, Russian Geological Research Institute, and Russian State Hydrometeorological Institute. We carry out several tasks and work packages in this project, but I'm here to tell you about the task to create and test a prototype GIS-based tool for marine spatial planning. And the approach in this TOPCONS project is that developing efficient measures to protect marine ecosystems requires interdisciplinary approach. And ecological knowledge needs to be integrated with information about human pressures. And there are already some interactive and clever technical solutions to aid in interpreting the accumulated knowledge, and the knowledge should be communicated to the stakeholders in a transparent way. The project area is the easternmost Gulf of Finland, the Russian waters, and the sea area in the Kymenlaakso region in Finland. And the data sets for the tool development have been collected from the existing available data sets about geology, biology, and hydrography. And the project has also collected new data from special intensive sampling areas. There's modeled data about key species. There are bird breeding areas and fish spawning areas included in this tool, and also information about human activities, their location and effects to the environmental parameters, and also the stakeholder evaluations from questionnaires and interviews have been or will be included in this tool. And the human pressures that have been chosen for the tool, I have to stress at this point that this is very much a work in progress. So, and this is a test version of this tool, so the list is not exhaustive, and there are also other pressures from these human activities than listed here. But the human activities are increase of oil transportation, offshore wind power, dredging and dumping activities, cooling waters of power plants, and fish farming. And data for these is collected from literature, expert interviews, and modeling. The stakeholder evaluations that are included in this tool will be or are being collected by interviews from 4 stakeholder groups. These are researchers, educational organizations, decision makers, and general public. And these groups are asked to evaluate certain, for example, key species, how important they deem them to be, from a scale 1 to 5. And then the answers from these groups, or the distribution of these answers, will be listed or will be inserted into tables as distribution of valuation scores between these classes. And the data sets will be combined using Bayesian networks. And these have been chosen because these are models that consist of variables relevant to the problem. They provide a quantitative means to study alternative decisions in the presence of multiple aims. They are transparent and a consistent method for inductive inference. They use probability as the measure of belief and calculate the process. And maybe most important of all, updating the model is easy with new observations. And the model structure at the moment looks like this. On the top part of the graph, there are the human activities and the pressures that they cause to geological and environmental parameters, and they in turn affect the key species, fish nursery or fish spawning areas and bird breeding areas. And on the bottom part of the graph, there are the stakeholder valuations. And how will the tool then work? First of all, the species occurrences prediction without human pressure is the starting point, the current situation where the species are located. And the Bayesian network assesses the impacts of human pressures on these species. It's risk analysis measured as loss of these species. And also in this tool will be included the area that is affected, the distance function for these pressures, and also the mean circulation will be included. How this affected area changes when water movement is included. All these data sets will be transformed into grid size of 100 times 100 meters, rasterization of the data. And then the raster algebra takes place. It's a risk calculation for each of the grids. And the outcome of this calculation is then, or can be viewed from graphical GIS interface. There you can see on the map impacts to species occurrences after disposition of human activities. And it's an easy way to observe where species will be vanishing or other effects will be visible when you just look at the map. The first version of the tool will include these pre-selected human activities and their pressures, geological and hydrographical parameters defining the species distribution, and probability of species distribution in the study area. And you can view the changes in species presence/absence due to human pressures. But in addition, you can view the original GIS layers and metadata sheets, and also the location, for example, protected areas. And as for planners, they can view the stakeholder valuations either separately in each group or the combined view of these groups. And what could be then included in the next versions if this approach is applicable? Now there are only species presence, absence data, but it is possible to include abundance. It's also possible to include recovery of the species after short-term disturbance. And of course, more human activities and their pressures are easily applied to this model or tool. The socio-economical valuation of the areas and also the effects from the activities taking place in the drainage area. And this approach or this application can be transferred to other areas as well with suitable background data sets. If you wish to have more information about this tool, please contact Riikka Venesjärvi. Some more information about the project in general can be received from merikotka.fi/topcons. And I would like to use this opportunity to announce the final seminar of the project. It will be held in Helsinki on 25th of November, and you are all very welcome there to hear more about this tool and the project in general. Thank you very much.
Yes, it's a bit tricky. Yeah, thank you, Miina. Just stay here, please. This is an interesting topic, I think. I'm pretty sure that we will have a few comments on this. Kees is already smiling. I don't know whether he's just smiling because he's in a good mood or...
I think it's a very ambitious project, and I was quite stunned at the grid density you are working with, 100 by 100 meters. Whereas I know, for instance, ICES data is collected in grids by 5 by 5 nautical miles, I think. So doesn't that strain your model, this difference in density?
I hope I can answer your question. The environmental parameters and the background data sets from the Eastern Gulf of Finland, they have been collected from quite a small grid size, and all these parameters have been modeled with this grid size, at least even more accurate grid size. So the data sets are quite reliable behind this model and tool. I mentioned the intensive sampling areas, and there the grid size is even smaller. So we try to be ambitious with this approach.
That's great if you can do that.
We try.
This is really very interesting. Now it's starting to look like something. I've been included in Holbas, not a Holbas, but following Harmony in North Sea about layers and layers of pressures, no weighting, no relation between the different things, and I didn't like that very much. I'd like this more, but you got one point that I'm struggling with in Norway, and also asked to check what is the natural density of species with no human impacts. However, I may able to find such data.
What would you like to add on this?
So I just wanted to ask the same question because you mentioned that you will develop within the project tool which will include changes in species due to human pressure, and there are there might be different pressures. They might be positive, negative, and maybe also neutral. And that was exactly my question. Do you consider also these areas, relationship between species where this human pressure is not taking place? So exactly my question. So thank you.
The background data sets about the current distribution of species or occurrences of species is the starting point for the model. And the occurrences that are before and after human pressure are modeled ones, and the model data before the human effect is verified from field studies. So we assume the models be quite realistic and reliable for the current state of the species occurrences. And unfortunately, I cannot answer the joint effect of human activities to, or the interactions of species occurrences after human impacts. I think the model at the moment calculates the species occurrences from these physical parameters and hydrographical parameters. And these co-effects might not be included yet, but it's possible, I hope.
Yeah, I have a question. If this model, so what you introduce, it's probably something similar what has been applied, this Markson model, which is also applied for maritime spatial planning. Since I have not been using that model also myself, I don't know really specifics of that, but maybe you could elaborate what is advantages of this model, or has it been more elaborated in which direction, where, what you... so.
I'm sorry, I'm not familiar with that model, so I have to, or I can forward your question to Riikka Venesjärvi. She can probably tell you more about it if you wish.
Yeah, thank you very much. I will try to elaborate a little bit along these lines. We should distinguish here two things. One is the data, GIS, map layers, all these things. This is, data collection, data modeling, GIS modeling, all these things. This is input. Another thing is the Bayesian network. Bayesian network is a universal thing. You are using the software and you are building the network according to your imagination, what is influencing what. Influence diagram. It means that these two things, these both are tools. GIS is tool to work with data. Bayesian is tool to create the influence diagrams. And now the point is to use this data to fill in probability distributions, input, and to calculate the output. And this is the art, high-level art. If the influence diagram is as close to reality as we can, then the results as a probability distributions, it's not yes or no. It is probability of this part of yes, more yes, less yes, yeah, and this just to answer your question, but beauty of that is that we are trying to capture uncertainty. Normally, planners are, how certain it is. Everything uncertain from the point of view of reality. And Bayesian networks are one of the powerful tools for that. Thank you.
If I directly may add on this, in one of the early slides you mentioned that TopCons tries to provide a tool which allows stakeholders to get transparent access to scientific knowledge. And if you return to the slide you just had on the Bayesian belief networks, then I asked myself whether this is something that stakeholders actually accept, because this sounds like a scientist's dream to have a complex network of just put something in and then there's a mechanism who calculates all the different things. And then you get an output, you get nice maps, and you can give them to stakeholders or policymakers and say, hey, if you want to have this, then that will be the solution. But if you want to have another alternative and your values are different, then this will be a solution. Did you make experiences with stakeholders whether they say, okay, this is acceptable, or this is already a black box that we do not trust anymore?
Well, this part of the tool development is still in progress. So we are looking forward to interesting comments from the planners.
Two of my questions have already been asked by others, so I've only got one remark and one question left. The remark is about the pressures. As you said, it would quite easily be possible to include more pressures. I think it would make sense to include shipping in general, irrespective of oil transportation, because that's really important, I think, also in the Gulf of Finland. And thinking of a Baltic scale, because I think it would, of course, be interesting to apply this model also in other regions of the Baltic. I think that also fishing would be important. And my question is about this species distribution model. If I understand you correctly, this is to species level resolution. So my question would it be possible to particularly look at red-listed species or to somehow weight the model to give more importance to red-listed species?
Thank you for your comment and the question. At the moment, the list of species that is included in the model, it's about 25 species that are occurring both in Finnish and Russian waters. There are fish, algae, mussels, vascular plants, and some of these are red listed, and it is possible to weigh these red listed species more so that they are taking into account. Actually, the original idea was to keep them separate from these other key species, but now they are included in the same compartment of this model, but they can be weighed separately.
Yeah, then I would say thank you, Miina.